7.3, by the end of this lesson, you should be able to calculate or find the missing measures of a 45, 45 right triangle. Okay? So 45, 45 right triangles are simply right triangles that have 45 degrees at the acute angles, which makes this isosceles, and that means the sides or the legs have the same length. So these are the legs, and this is the hypotenuse. I'm going to abbreviate it. Remember, the hypotenuse is opposite the right angle. So we're going to apply the Pythagorean theorem to see if there's a relationship between the legs of a 45, 45 right and the hypotenuse. So we have labeled each of these legs measuring n. So that means I have n squared plus n squared equals c squared. Combining like terms, I have 2 n squared equals c squared. Okay, we're wanting to solve for c, so we need to undo squaring. We undo squaring by taking the square root. So that gives me c equals, if I take the square root of n squared, I have n outside the radical and a 2 under the radical. So here is the steps you would take if you know the leg and want to find the hypotenuse. You multiply by the square root of 2. So over here we knew the leg was n, and so we simply multiply by the square root of 2 to get the hypotenuse. If we know the hypotenuse and we want to find the leg, we do the inverse operation of multiplying, which is divide. So we're going to divide the hypotenuse by the square root of 2, and then we're going to rationalize our answer if necessary. So let's go through some of these examples. This is find the value of each variable. So notice here, A is opposite the right angle, so we are looking for the hypotenuse. And when we're looking for the hypotenuse, we take the length of the leg and multiply it by the square root of 2. So we get A equals 3 times the square root of 2. We look at the next problem again. We are solving for the hypotenuse. So B equals 5.5 times the square root of 2. Now in this third one, we're wanting to find the length of the legs. If we know the hypotenuse and we want to find the leg, we take the hypotenuse, which is 3 square root of 2, and we divide it by the square root of 2. Notice we have square root of 2 in the numerator and denominator, so these cancel out, and we get the length of each side is 3. Coming down to this example, again, we're given the hypotenuse, we're trying to find the legs, so we're going to divide the hypotenuse by the square root of 2. Okay, now here's where we need to rationalize. We cannot leave a radical in the denominator, So we're going to multiply it by the square root of 2 over the square root of 2, which is equivalent to 1. And anything times 1 has the same value, it's just going to look different. So we're going to multiply the numerators, 5 square root of 2, and notice we're multiplying the square root of 2 times itself twice, so I'm going to rewrite it this way. And when you square a square root, your answer is going to be the value under the radical sign or the radicand. And so C equals 5 square root of 2 divided by 2. And this is your rationalized answer. And this is the format you need to have it in. Okay? Moving over to this example here, we're trying to find the hypotenuse. To find the hypotenuse, you take the length of the leg and multiply it by the square root of 2. So this is now going to become, we keep the 5 on the outside, but we multiply 5 times 2 because they're both under the radical. That gives us 5 square root of 10. And we cannot simplify that, so this is our final answer. In our last example, we're looking for the length of the legs. So that means we're going to take the radical, or I'm sorry, take the hypotenuse, divide it by the square root of 2. Again, we cannot have a radical in the denominator, so we multiply by square root of 2 over square root of 2. In the numerator, we have 4 times square root of 3 times 2. And down at the bottom, we have the square root of 2 quantity squared. So that now gives us 5 times the square root of 6 divided by 2. Now, you can reduce outside the radical or, like we did up here, inside the radical, but you cannot simplify from outside the radical inside the radical. So 2 goes into 2 one time, goes into 4 twice, so our final answer is 2 square root of 6. On the back of your page, you have what's called the unit circle. This is a good reference, and it's broken up into 45-degree angles. Okay? Unit circle means that you have, this line is 1. It's also the radius, so that means every single one of these is 1. And we can find the coordinates of this point using the Pythagorean theorem. But what we're going to find, since this is a 45-degree angle, we take our hypotenuse, divide it by the square root of 2. Our hypotenuse is 1. Divided by the square root of 2. Again, we have to rationalize it. We get square root of 2 over 2. So the coordinates of this point here is the square root of 2 over 2, square root of 2 over 2. Over here, this is also 45 degrees, but notice we're in quadrant 2. In quadrant 2, our signs change. Our x is negative and our y is positive. So the coordinates for this point is negative square root of 2 over 2, square root of 2 over 2. Continuing around, this is quadrant 3. Our x is negative, our y is negative. Negative square root of 2 over 2, negative square root of 2 over 2, and continuing over into the fourth quadrant, where your x is positive and your y is negative. This becomes the square root of 2 over 2, negative square root of 2 over 2. Okay? Now, one more piece of information about the unit circle is your coordinates x, y correspond to your cosine and your sine. So, if I want to find the cosine of this angle here, which is 135 degrees, it would be negative square root of 2 over 2. So this is a quick and easy reference on your 45, 45, 90 triangles.